Alrighty, we are given a circuit and we are asked to analyze this circuit using Thevenin equivalent voltage and resistance, right? Now to do this, we would first obviously try calculating the Thevenin resistance. Now in Thevenin resistance, all the voltage sources become short circuit, right? And all the current sources become open circuits, yeah? So redrawing that based on the condition, it's going to be something like that. We will come here. We would have a 1 ohm resistance. There's a right, and the load will always be removed. Yeah, so we remove the load. We get a 3 ohms there, and there's going to be a B, and then there's going to be a 3, and there's going to be a 1. Yeah, that's how it looks like. Now obviously you can sort of now we need it across 2 points A and B, right? And the way to go about this is you can have a point and you can have another point B, and you notice how these two ends, this and this, are kind of shorted together, right? So I can short them together. I can have one end of it connecting to 1 ohm, yeah, and another end of A is again connecting to 3 ohm, but the 3 ohm and the 1 ohm are shorted. So we can have something like that. It's shorted together, and we can draw the same thing over here. There is going to be a 1 ohm and there's going to be a 3 ohm which is shorted together. Um, Now they both are once again shorted together, right? So it's something like this, and when you try simplifying this section, it's obviously they're both in parallel, so it is 1 times 3 by 4, and the same thing over here. It is addition because they're now in series, and it's 1 times 3 by 1 plus 3, which is 4, and you basically get 2 times 3 by 4, which is equivalent resistance is equal to 3 by 2, right? This is equals to our equivalence or Thevenin resistance. Yeah. So once we have figured this out, the way to go about solving for VAB is, again, you sort of ignore this resistor. Yeah, and then you get two branches. You get, this is one branch, I1, and you get another branch, I2, and then you sort of try to get this loop. Yeah, when you solve for this loop, you get AB. For that, we would need the voltage drop across this and voltage drop across this. To be able to do that, you would need to calculate currents I1 and I2, which is what we'll try to do about now. Let me just draw the circuit again somewhere down. Yeah, so you have 1 volt. We'll try using a different color. Yeah, so you have a 1 volt, and then you have 1 ohm, yeah, and then it's simply gone down and you have a 3 ohm here, and it comes over here where you have a 3 ohm, comes over here where you have a 1 ohm, and voila, right? So you essentially have this circuit over here, and what we are concerned with is obviously the sort of current which is passing through the circuit. One thing you can consider doing now, since we need the voltage drop across this and this when we draw this equivalent loop, we will first have to calculate the current which is passing here and the current which is passing here. And to do that, you can first try calculating the equivalence current. The way to do that is this whole thing would be 4, this whole thing would be 4, and the sort of parallel connection will give us 2. And obviously, current is equal to I by R, V by R, right? So our V is going to be 1 and R is going to be 2. So the current, the equivalent current, which is passing through this entire circuit is going to be 0.5 amps. Yeah. Now we'll have to understand how the current is splitting across this branch and this branch. Now, one thing to note is both the branches have an equal distribution of resistor. So both the branches will receive the same amount of current, which is 0.25 amperes. Yes. Now that essentially implies that this resistor has 0.25 amps and this resistor has 0.25 amps. And now when you draw the loop which we are concerned with, the loop starting from here, right? And this is our VAB, right? VAB. And we will draw a loop from here, come all the way down, go across here, come down, and come here. So that's our whole thing is a loop, right? And in that loop, you notice 1 volt. First, we'd start with this resistor. It's 3, and the current it's IR, so 3 times 0.25, yeah. And we come across VAB. This is the negative end of VAB, so it's going to be minus VAB. This is the positive end, and then we come over here, which is again positive, so it is 3 times 0.25, and we come to negative 1 volt, which is negative 1 volt, and that will give us VAB. Try simplifying this, you'd get 5, 6, and 7, so 0.75. And then you have 0.75 again, so times 2, minus so that's going to give around 1.5, right? Minus 1 minus VAB is going to give us VAB, and that's going to give zero point 0.5 comes this side. So VAB essentially is equal to 0.5 volts. Now VAB or VTH is equals to zero point 0.5 volts, right? So that's our Thevenin equivalence voltage. And when you redraw the entirety of it, you would get something like that. You would have 0 0.5 volts, comes all the way there, and the series resistance, the Thevenin resistance, is obviously 3 by 2, which is 1.5, right? 1.5 ohms. And we can include our load across here, whatever our load is. So that is the answer, right? So this is how you go about solving such questions. I hope that might or might not have clarified your doubts. Have a good day.